How do you accurately measure fractal dimensions in nature? Imagine trying to measure how complex a coastline is or how detailed a cloud pattern appears. Natural shapes are often irregular and intricate, making them tricky to analyze. That's where fractal dimensions come into play. They help us understand how much space a pattern fills as we look closer or farther away. To measure these dimensions accurately, we need to follow a few key steps. First, we choose the right type of fractal dimension. For natural objects, the box counting method is most common because it works well with irregular shapes that aren't perfectly self-similar. Next, we gather data at multiple scales. This means taking high-resolution images or measurements that capture details from large to tiny sizes. It's important to identify the scale range where the pattern behaves like a fractal, called the scaling region. Outside this range, measurements can become inaccurate. Then, we overlay a grid of boxes of a certain size over the image or data. We count how many boxes contain part of the pattern. We repeat this process with smaller and smaller boxes. When we plot the logarithm of the number of boxes against the logarithm of the inverse box size, the slope of the straight line in this plot gives us the fractal dimension. For surfaces that stretch differently along different directions, called self-affine surfaces, we need to be careful with how we measure. Aligning the measurement plane parallel to the surface helps avoid errors. Advanced techniques like Slit-Hyland analysis and Richardson's method can improve accuracy, but they requiring more effort. To make measurements more reliable, scientists often use computer algorithms and simulations. These tools help estimate confidence levels and test if the pattern's fractal behavior holds across scales. Methods like maximum likelihood estimators or nearest neighbor approaches are also used to refine results. Once we have the fractal dimension, it tells us how complex or dense the pattern is. For example, a coastline with a higher fractal dimension fills space more thoroughly than a smoother one. Soil particles and plant structures also show fractal properties, which can reveal information about their composition and growth processes. In essence, measuring fractal dimensions in nature involves choosing the right method, collecting detailed data across scales, carefully applying measurement techniques, and using computational tools to verify the results. This process helps us connect the abstract idea of numbers to the real-world patterns we see all around us.